All right, so as we said before, the lines that will go through these points are going to come later. Now we're actually going to look at those lines. So in the first part of Explore part A1, the lines in figure 1 and 2 below represent two different equations or models for the data. The line in figure 1 connects the points at the left and right ends of the plot. The line in figure 2 passes among the points but hits none exactly. Which of the two lines seem to fit the data better? Explain your choice. So take a look at figure 1 and figure 2. Figure 1, it goes through the point that starts at 1 and it goes through the point that ends at 6. So according to our table up here, 1 was at 12 and 6 was at 64. So 1 is going through 12, 6 is going through 64. Figure 2, the line goes through none of the points exactly, but it looks like it goes through the middle of all the points. So what you're going to do is you're going to look at those two lines and you are going to decide which one do you think fits better. And then you have to remember to explain your choice. So why do you think that looks better? Why do you think that that line is a better model for the data than the other one? Then number two, can you sketch a line that is a better fit than these two? So you may not. You may not be able to sketch a line that's a better fit than these two, but just take a look and see if there might be something that you could do that would fit this data better. It would make it a better model. In B, it says to find out how accurate each model is, you can calculate errors in the predictions made by the model. Those errors are the differences between the actual data and what each model predicts. Each such error is called a residual. So if we click on residual, it will take us to a glossary. So a residual is the error calculated by finding the difference between an actual data point and the value that a model for the data predicts. So going back to our lesson, we need to fill in this table, copy and complete the table below for figures 1 and figure 2. So I see only one row for each of these, or just one row on each, the predicted and the residual. So to figure out or to put in figure 1 and figure 2, something that I might do is I might put in a text box and start with figure 1 and then enter and put in figure 2. Now in my lines over here, in my sections over here, I can look and see in figure 1, well, I know that that one was predicted 12 because it went through the point. And then underneath that, I could look back at figure 2. Now it looks like it's right underneath 12. Looks like it may be going through 10. So I'd put 10 underneath there. Again, I might do that same thing down here for the residual, figure 1 and figure 2. Now it says here that to find the residual, we have to do the actual minus the predicted. So in this case, figure 1, the actual was 12 and the predicted was 12. So it would be 12 minus 12, which would give us 0. In figure 2, the actual was 12, the figure was 10. So what we get instead is a positive 2. 12 minus 10 gives us that positive 2. So what you're going to do is you're going to get through figure 1 and figure 2 for all of these and complete the table, and then you're going to answer some questions about that table. Number 1 says the first line goes through points 112 and 664. The equation for this line is y equals 10.4x plus 1.6. How would you describe the errors of prediction or the residuals for this linear model? So you're going to need to figure out what are the residuals for figure 1, and then you would look and see if there's a pattern or look and see if there's anything that stands out to you about these residuals. Number 2, Sally thinks the equation for the second modeling line is y equals 10x. Do you agree with Sally? Explain why or why not. So Sally is looking at figure 2 in this case. So you can look at that figure, that graph for that question. But then the next question, number 3, how would you describe the errors of prediction or residuals for Sally's linear model? Then you would look at the residuals for figure 2, the ones you have along the bottom here. That's going to help you answer question number 3. Number 4, do the residuals suggest that one of the models is better than the other? So then now you have to compare the two, figure 1 and figure 2. Look and see if the residuals are going to tell you if one of them is a better fit than the other. Section C, you can find linear models for many situations. The student paint crew gives weekend and vacation jobs painting houses and apartments to high school and college students. The time a job takes depends on the area to be painted. Prior jobs give some data relating job area in units of 1,000 square feet and time to paint in hours. The table below shows some of the data. Now, I would probably pause the video at this point and make sure we have all of these questions answered before you go on to section C. Once you have all those questions answered, feel free to go on to section C with the student paint crew data. The first question in section C is telling you to plot the data in the graph in Desmos and put the graph in here into your assignment. Now remember, if you can't access this image section, please see your teacher for their code that will allow you to gain access to this image tool. Draw a line to match the data pattern on your graph above. So we're going to use the drawing tool in Kami. So once you create a graph here, what you're going to do is use the drawing tool to create a line through the graph. Now, obviously, I don't have a graph here right now, but once you have that graph, use the drawing tool to create a line, a model through that data. Then find the equation of your modeling line and find the residuals for the model you developed. Explain what they tell you about the accuracy of the linear model. All right, that is the end of this Explore section. You can pause the video or end the video and watch the video for the independent practice when you're ready.